Hey guys, so here we are. Right now it's Sunday night when I'm filming this. Eating some there we go, Ben and Jerry's. Trying to keep up my energy to do some stuff now that my kids have gone to bed. But there's something weird about the energy that we use. So that's what we're going to talk about today is adenosine triphosphate. We know that we get energy from food, but it's not like food is directly the energy that our body can use. Like I can't just look at a spinach leaf and get energy from it. I can't look at the mocha and caramel ice cream with chocolate cookies, fudge flakes, and a chocolate cookie core and just be like, yep, this is going to be exactly the energy that my body wants and needs right now. So how do we get energy from our food to help our bodies function? Well, we know we need energy for our cells, but we can't directly use the food for energy. But the energy that's in the food is stored as chemical bonds. So all we have to do is break apart the chemical bonds and kind of like release that magic energy so that our body can then carry out the cell functions. So we use ATP, which is adenosine triphosphate. A is adenosine, T is for tri, and phosphate is P. So the ATP carries and stores the energy for all of our cell functions. The ATP does not directly eat my Ben and Jerry's, but the Ben and Jerry's has the different chemical bonds that release the energy for my cells to use. And this is the only molecule that directly powers your body. It's extremely important. Our bodies get energy from nowhere else besides this ATP. So we're going to cover it in 5 slides. So here's the structure. I kind of think it looks like almost like a robot dog. Like you got the big nose and there's an antenna and then like a really long tail. I don't know. That's kind of what I see. So we have a nitrogen base, and that's called our adenine. So these two structures right here that are highlighted, mostly in green, that is the nitrogen base. So that's the A from our ATP. Then our sugar ring, which is our ribose, that's going to sit right down here. And then we have 3 phosphate groups. So we have like these 3 plus signs at the tail, and those are held together with high energy bonds. So if you remember back to physical science or last year when we didn't quite get to it, everything in a atom and in the nucleus is held together super tightly. It's like a really strong magnet that is pulling everything together. So that's happening here is we have super high bonds that are like, yep, nope, I'm holding on for dear life and I'm not letting go. And so what we can do with those bonds is actually break them apart to release the energy. So a lot of energy is stored between those last 2 phosphates. So we have like this super long doggy tail, and we can remove a phosphate group. And when we do that, we are breaking it apart and releasing the energy that was holding those 2 things together. Then we form ADP, so adenosine diphosphate, because di means 2, tri means 3. So up here we had 3 phosphates, we broke one off, and then we came down here, and now we only have 2, so we're adenosine diphosphate. And that diphosphate wants another phosphate added back to it, so it puts one back on, and then it can get broken off again and release some energy. So we are continuously releasing energy from ATP to ADP, and then using energy when we break down food to add that phosphate back on. We're going in one big cycle. I have 3 phosphates, ATP, I break off the tail of it, and I release energy. Then I eat some food, I put a phosphate back on, and then I break it off again. And we're just adding and removing that last phosphate over and over and over and over again. And the energy that's released when we take that phosphate group off is what our cells use. When ATP is broken down, so our 3 phosphates, it releases energy for the cell to use, and then becomes ADP because we have 2 phosphates. And when we do that, our ATP separately is broken down into ADP, a phosphate, so just P, and then the energy that we release. Because we are releasing energy, this isn't going to show up for some reason right now, but we are letting go of energy in this chemical reaction. And so when we have less energy than when we started, it's exothermic. Energy is exiting. Now to make ATP, so we're at ADP right now, and we want to remake the ATP, cells have to take that ADP with 2 phosphates, and then the extra phosphate that's just floating around out there, and they use energy from food to reattach it. So our ADP, so our 2 phosphates, plus the 1 phosphate that's floating around, plus energy that we now get from our food, forms ATP again. It sounds very complicated. I promise you it is just a simple cycle. We go from 3, then we rip that third one off and release energy. And then we want to put that third one back on. So we take energy to put the third one back on. And then we rip it off again. And then we put it back on. Over and over and over again. And because energy is taken in when we go from ADP to ATP, we are doing an endothermic reaction because we're putting energy into our chemical reaction. And then this is how we're going to form ATP during cellular respiration, which is something we're going to talk about hopefully when we're back in class together, right after photosynthesis. And so again, I don't know why those words are just now popping up, but exothermic and then endothermic. So where does it come from? One last time. We have macromolecules in our food. Yay. I love props. They're so tasty. So carbs are the most common that we break down for ATP because it's the easiest to access energy. So the energy that's super easy to access, we can get about 36 ATP from 1 glucose molecule. It stores 4 calories per milligram. Lipids are broken down next. They store about 9 calories per milligram. And then proteins we don't want to break down for energy because they do so much else. And they can store about 4 calories per milligram. Know that we are always going to break down our carbs first, and then our lipids, and hardly ever our proteins. And the energy that we get from those helps go into our cycle back up. Backing it up. Come on, back up faster. Right here, where we go from ATP, we release energy that our body uses, and then the food gives us energy to add that phosphate back on. So we release energy for cells, and then the carbs give us energy to put the phosphate back together. That's it. That is the cycle. We'll watch actually a review video over this concept tomorrow. Please let me know if you have any questions.